Now, suppose we have a surface like S. Our goal is to calculate an integral over the surface, over S. Over S. Well, the integral of function f, x and y, over surface S can be calculated. Let me just add C as well. F of x, y, and z is equal to, well, here if we write S as parametric form, x of u and v, y of u and v, and z of u and v, then this becomes the double integral of, now wherever you see x, you use u and v, y u and v, and z u and v. So in terms of f of r u and v times, well, here we need the magnitude of the cross product between ru and rv dA. Over the given region that your surface is defined over. For example, let's just go over one example to feel more comfortable about this formula. The question says, compute the surface integral of the function x squared ds over surface S, and surface S is the unit sphere x squared plus y squared plus z squared equals to 1. The very first thing that we should be asking is, how do we convert the unit sphere into a parametric surface? Going back to what we learned before, spherical coordinates. Using rho, phi. Note that rho is equal to 1 here. So we are not really worried about rho. Rho is 1 and x is rho sine phi cosine theta, y is rho sine phi sine theta, and z is equal to rho cosine phi. So your x becomes just sine phi cosine theta, y is sine phi sine theta, and z is just cosine phi. We have this conversion. What do we need? We need to take the partial derivative with respect to u, with respect to v, find the cross product, and then find the magnitude. This is what we have. So in this case, you can say that, hey, my u is phi, my v is theta, or vice versa. Well, let's do the calculation. Your r is equal to phi, and theta is equal to, well, the very first component is sine phi cosine theta, sine phi sine theta, and cosine phi. So let's take the partial derivative with respect to phi. Here we get cosine phi, cosine theta, we get cosine phi, sine theta, and this guy is negative sine phi. Partial derivative with respect to theta is equal to, this becomes negative sine phi, sine theta, this becomes sine phi, cosine theta, and this guy doesn't have any theta in it. It means that the partial derivative is just 0. Well, now we need to find the cross product between them, then find the magnitude. Okay, r phi cross r theta. I, j, and k. Well, the very first component is cosine phi, cosine theta, cosine phi, sine theta, negative sine phi, and the last row is negative sine phi, sine theta, sine phi, cosine theta, and 0. So this guy becomes I times this is 0, and here you get sine squared phi, cosine theta, minus j. Well, this becomes 0 minus sine squared phi times sine theta, plus k in the direction of z-axis, oh my god, which gives us sine phi cosine squared sine phi cosine phi, sine phi cosine phi times cosine squared of theta, minus, we get a plus sign, okay, and here we get sine phi cosine theta, sine squared theta, sine phi cosine phi, and sine squared theta. This is what we have so far. Now we have to find the norm, of this vector. So let me erase this part of the board. So here we have the norm of r phi cross r theta. So note that here, if you factor out sine phi cosine phi, this becomes 1. So this is equal to square root of, well, this guy becomes sine to the 4th of phi cosine squared theta, plus here you get sine to the 4th of phi sine squared of theta, plus, and as I mentioned, this is just sine phi cosine phi, so you get sine squared phi cosine squared phi. This all inside the radical. Okay, what we can do, if you factor out sine to the 4th of phi, this becomes 1. So sine to the 4th of phi, and here we have sine squared phi plus cosine squared phi. Let's see. Sine to the 4th of phi plus sine squared phi cosine squared phi. If you factor out sine squared phi, this guy becomes 1. So the outcome is just equal to sine phi. This element here is sine phi. Now we have to just plug x for x here. Our x is sine phi cosine theta, sine squared cosine squared, and then that guy is sine, so this guy becomes sine squared phi times cosine squared theta times sine phi. We get sine to the 3rd phi. then we can do the calculation. The calculation is easy for us. Phi is bounded between 0 and pi. Theta is bounded between 0 and 2 pi. And as we know, rho is just 1. It doesn't take into account. We already used that before. So this guy becomes the double integral . 0 to 2 pi, 0 to pi, and here we have sine to the third phi, cosine theta. D phi, d theta, d theta, d phi. Here we get. And if we do the calculation, the final answer is 4 pi divided by